So now let's look at the second problem, which has got something to do with the matrices. Okay, so let's look at this problem. Okay, example 2. So this problem is about movie ratings. Okay, so how do you rate? What is this problem? So essentially, when you rate a movie, for example, you have users. Let's say user 1, user 2, and so on. There are, let's say, user n. Okay, so there are n users who are watching movies on Netflix or whatever, and there are so many movies, right? Movie 1, movie 2, and so on. Let's say there are m movies. Okay, so now what happens is, each time a user watches a movie, he will be asked to rate it. Let's suppose he rates it. For example, user 1 watches movie 1 and he gives a rating y11, meaning let's say rating is from 0 to 10. If he thinks that the movie is very good, he will give 8 or 9 or something. If he says it's okay, watchable, then 6, and so on, right? You know what that is, right? And I will scale it by 10, so I get a number between 0 and 1. So suppose y11 is a number between 0 and 1. That's your rating. And obviously, use all, every user cannot watch all the movies. Maybe, user 1 haven't watched, let's say, movie 2, so it's blank. I'll denote it by star. Star means he has not watched that movie. Let's say he has watched the mth movie, and the rating is YIM, and so on. Okay, so let's say this is again star, and he has watched the next movie y12, and so on, and then star, and so on. Okay, so you know how to fill this matrix, right? This is the movie rating matrix. Okay, now suppose, let's say, user 1 is a friend of user 2, let's say close friend, and they have similar tastes in terms of watching movies. So the ratings will also be similar. Do you agree with that? Yes or no? Right?
Yes, sir.
Right. Okay, so supposing I make that assumption, in this group of users, there are several users who are very much closer to each other, in the sense their tastes are similar. So given that, can you so this is an incomplete matrix, right? So this is an incomplete matrix, right? In fact, you can think of it as data. Now I have to complete it, right? So meaning I have to tell what is user 1's rating for movie 2. If I have to say that, right? Suppose the rating turned out, if I fill this matrix and the rating turned out to be 0.9, let's say, out of on a scale of 1, then I should recommend this to user 1, and user 1 will watch, and therefore I can make a lot of money, right? So everything boils down to money, right? So this is why these kind of problems are very important. So now you have to fill in these gaps or missing data. Or this problem is called matrix completion problem. Okay, so matrix completion problem. How many of you have heard of this? How many of you have heard of this matrix completion problem? No one? Okay, so there are quite a few people who knows what matrix completion problem is. Good. So this is what matrix completion problem is. You have to fill in all the ratings so that you can recommend good movies or not recommend bad movies. So now, how do you fill this? Well, in some sense, it's impossible to fill, right? Unless you make some assumptions. So what is the assumption? There are users who are similar, right? So let's say similar users. What do you mean by similar users? Well, for example, the ith user is similar to jth user. So what do you mean by that? So if you look at the vector corresponding to ith row, right, and vector corresponding to jth row, that is, for example, if you go back, suppose there is ith vector here, that is your rating, this particular rating, okay, and there is a jth user here, I and j, okay, so this is your They are very similar, meaning their ratings are kind of aligned. So what do you mean by that? It means I can assume that y1 is kind of related to y2 through some alpha, right? It's some scaled version of the other. So if I know his rating, I can just scale it and get the rating of the other guy, right? In some sense, if you want to geometrically look at it, so for example, yi is this, alpha yi could be something like this, right? So this is alpha yi, which is yj, right? It lies in this on the same vector, right? So now if you have vectors which are related in this way, linear scaling, what kind of a matrix is this? Can somebody tell me? Those who have taken linear algebra, you have studied linear algebra, right? All the BTech students for sure they have studied linear algebra. So what does it relate to? Suppose I have a 2 cross 2 matrix. I can think of the first row as a vector, second row as another vector. So first row is 2 times the second row. What kind of a matrix is that? Can somebody tell me?
Dependent.
No, these are dependent vectors, right? So when you stack two dependent vectors to make a matrix, what kind of a matrix is that?
Singular one.
Hmm?
Singular matrix.
What matrix? Can you repeat? Sorry, I couldn't hear you.
Singular, sir.
Singular. Okay, so that is correct. It's a singular matrix. So are there any other jargon or equivalent name? How many of you have heard of rank? Rank of a matrix? No? Okay, good. How many of you have not heard of rank? Okay, let me ask you that. Surya, you have heard of rank or not heard of rank?
I
Surya,
have heard of rank.
you have heard of rank. So those who have not heard of rank, okay. Anyway, so don't worry, we will look at some aspect of it. So essentially, what it means is, this this implies that the matrix or the movie rating matrix, right? Movie rating matrix is what is called rank deficient, right? So if I assume that there are too many users who are related to each other, they think alike in terms of movies. So the problem that I would like to solve is the following, right? So what is the problem that you would like to solve? I want to fill in those entries, right? In other words, if I look at the rank of, for example, this matrix X, I'll call this matrix X. Okay, so this entire matrix, I will call it as X. Okay, I'll call this matrix as X. So I want to find a matrix whose rank is as small as possible, right? Minimize over all X. Okay, so that's what I want to do. Well, this is if I just give you this problem, the problem is very, very trivial, right? Why? You give all zero matrix, right? That will be your this thing. Or yeah, so but then remember, you cannot give all zero matrix. Why? Because I have entries here, right? Y11, Y12. So you should, those entries should not change. I just have to fill in something that's not, somebody hasn't rated the movie, then I have to fill in those numbers. So now I have to say subject to, that means I want to find a matrix with the least rank. But if you look at, for example, the ijth entry of X, that should be same as Yij. Yij is the ratings given by the user. Whenever Yij is not equal to star, I mean, whenever the entry is there, right, then Xij should be equal to Yij. Wherever the entries are not there, you are free to choose whatever you want, but make sure that the rank is as small as possible. Okay, so this is another example. It gives rise to two things, right? So the first tool is, of course, matrix theory or linear algebra. And you also need optimization here. Well, this optimization is a very complex or a very hard problem to solve. This is what is known as, you will see what this is. This is called non-convex problems. Okay, don't worry about these jargons. You will You will understand what this means later on. Okay, non-convex problems. Well, matrix completion problem, which is a very, very practical problem. Many companies want to solve this. This problem turns out to be a non-convex problem, and whoever solves it in an efficient fashion will kind of make a lot of money, right?